Hello again. So now we are going to figure out how to calculate shadows in perspective. And to start, we're going to start with sunlight, because sunlight and artificial light are going to work different. Relatively the same, but there's going to be a few minor differences between the two, and it has to do with how far away the light is from us, but we will get into that. So first, we're going to talk about sunlight in perspective and how to calculate it. So the first thing we have to talk about is our parallel lines. Parallel lines. If you recall, I said when you're dealing with sunlight, the sun is so far away from us that the rays look like they are parallel to each other. So to help us envision that, I want to do a side view here of a cube. And it's here on the ground. So I'm just going to put side view so we know. Okay, and what happens is our light is going to be coming down at parallel lines. So we're looking at a side view. If we had, special goggles on where we could actually see the light, what you would do is we're going to draw our beams of light coming down, and our sun's somewhere off to this side. We draw a beam coming down, connecting through a corner of our box to the ground. And the reason we're doing that is because what a shadow is, remember it's called a cast shadow because it is casting a shadow on the ground. So you need to find out where that top edge is going to cast a shadow onto the ground. And then I'm just going to draw a few more rays in. All the rays are going to be parallel, so this ray would be coming in and hitting this corner, and then this ray would be coming in and hitting this bottom corner. So this is what it looks like when the sun is shooting down. These are our kind of rays that we're envisioning here. So where this comes down and hits here, this is our cast shadow, because it is being cast down from the top corners of our cube, this area right here. So let's look at this again in a more isometric view. So if I was to draw my cube from the side, looking down at it, okay, then we're going to be imagining the same scenario where the sun's coming down from the side here. We're going to draw the same thing. We're going to draw the sunlight, our beams of light coming down. Actually, before I do that, let's quickly figure out, I want to figure out where the bottom edges of this cube are lined up, because this is going to make it a little bit easier for us and kind of help us envision it sitting on the ground. So I'm just going to make a line going horizontally across from that bottom edge, from these two corners. And then we need to figure out, or kind of imagine where this back corner is. So let's imagine it's about here. We're going to draw that out. So it's helpful to know that, helps to see where these corners are actually sitting on the ground. Okay, then we're going to go and draw our beams of light. So draw this line coming in through here, through this top corner, and where we're going to stop is where it's, hitting this area that lines up with our corner. So that will stop right here. That's where it's hitting the ground, basically. Then we'll do one from this side. It'll go through that corner into the ground. This is where it would hit the ground. And then this one here, that's behind, do the same thing. And it's just going to be hitting the ground there. So then to figure out what the shadow looks like, all you now need to do is pay attention where these three dots are, where those lines connected, and then you just connect the dots. Now this one would be going all the way back to that edge back here, but we can't see that, it's behind the box, so we don't need to do that. We only need to do the part that we're going to see. So this is what our shadow looks like. All right, so it's going to be a matter of calculating where the sunbeams hit the ground is how we're going to be figuring this out in perspective. Okay, so let's move on. Let's actually do one in perspective now and see how this works. Now, I told you that the sun lines or sunbeams are parallel, but when we are drawing in perspective, because we are creating the illusion of depth, we are going to have, it's going to look like our sunlight is, converging, because that's how we give the illusion of depth. So it's not gonna look like it's parallel, but if we were to look at this from a top-down view, they would still look parallel. It's just our way of making our kind of illusion of perspective here. So we're gonna start with our horizon line like we always do. Horizon line. And then I'm going to draw a quick cube. I mean, I'm essentially making this up here. Using my ruler the best I can, so I'm not completely eyeballing this. Okay, let me just get rid of these extra edges here. So here is our cube in 2-point perspective. And let's get rid of these so you don't get confused. Okay, so there's going to be several steps to this. The first step is you have to figure out where your light source is coming from. So since we're doing sunlight here, it is where is your sun. So we want it to be behind our object, so in front of us, somewhere over off to the side here. So I'm gonna put my sun right here. So this is my light source. Okay, now we wanna figure out, what's the angle our shadow is gonna be. We know, because our sun is here, what's gonna happen is our shadow is gonna be coming somewhat down this way. It's gonna be back on our side of the object. But the question is, how do we figure out, what's the angle of it? So what we're gonna do is, we need to find a shadow vanishing point. To do that, we draw a line going directly down from our light source to our horizon line. And this is what we call our shadow vanishing point. So I can just put SVP. And this is how we figure out the actual direction of our shadow, where it's going. And it's always going to be on the horizon line, always, when we're dealing with sunlight, because the sun is so far away from us that it just essentially is receding back to the horizon, receding back to nothing. So with our shadow vanishing point, we first want to figure out where is our shadow? What does it look like? What direction is it going? So to do that, we're going to take our shadow vanishing point and connect it to the bottom corners of our box. So go to this corner, and I'm just going to go straight through it. And then this one will go through to this corner. And then this one will go through to this corner. Now, I'm not going to do all 4 corners. And the way this works is you only need to do this to the corners that are farthest away from the light source. Same thing like I did here. You notice I didn't do one from this light source, this line here, because this is closest to light source. This corner is not casting a shadow, so you don't need to figure out how it would look. So like this one here, because it's closest to the light, it's not going to be casting a shadow. So we only need to do 3 corners that are farthest away from the shadow. So now we know this is where our shadow is going to be. It's going to be in this shape. But then we need to figure out how long our shadow is. Is it really long back here? Or is it really short back here? And that all has to do with our light source. So now what we're going to do is, like we did here, remember the line going through the top corners down to the ground? That's what we're going to be doing here. So we then take our light source, have a line going from this through the top corner and then down to that shadow vanishing point. And actually what this, I did forget to mention here, these lines coming from our shadow vanishing point, that is actually called the direction of light. So I did not mention that. I want to go back and put that in here. It's our DOS. This is our direction of light, and that helps us figure out the direction of our shadow, essentially. Okay, so now that we have our direction of light, then we go up here, connect this from the top light source to the top corner to our direction of light lines. We'll make a little dot there, because this is the line connecting to this same side. And then I'm going to do this side here. So connect a line from my light source through the top corner to the ground. And then same thing for the last one. Going from the light source through the top corner to the ground there. Okay, so now I've just figured out the shape of my shadow, and all I need to do is connect the dots. And really, that's all there is to it. And so these lines coming down here, this is called our angle of light. So AOS. So there's 4 steps to doing shadows in perspective. And that is find your light source. Find your shadow vanishing point by making a line that goes directly beneath it on the horizon line. That's your shadow vanishing point. Find your direction of light. That's the lines coming out of the shadow vanishing point. That makes the angle, this basic shape of our shadow here. And then the light source, making angle of light, helps us figure out how long the shadow is. Now, if you think about that, let's say you wanted to change the length of the shadow. Let's say you wanted a shorter shadow. You didn't want it this long. You wanted it shorter. To do that, you make your sun higher. Because remember, think about it, like the higher the sun is in the sky, the shorter your shadows are. If we were to keep putting this up and up and up all the way off the page, essentially would look like the sun is directly above us. So it would make the shadow look really, really short, so it's just underneath it. Alternatively, if we moved the light source down, so it was like all the way over here, now you'd see if we did this angle here, this would go all the way back here. So that means our shadow would be way, way far back here like this. So the height of our light source, the height of the sun, will affect the length of our shadows, and that's really important to know. Now, the only time we don't need to do all this, find the light source and the shadow vanishing point, is if the sun is coming directly from the side of us, from either left or right side. If it is perfectly perpendicular with us on the side, and that's when we get this. This is exactly what this was. The sun was coming from the side, and because we're looking at it from the side, the sunbeams aren't converging back. They're just going directly sideways. So it's in the side view that we can actually see that the light beams are parallel to each other. And it's only in this situation that we can tell because the light's coming directly sideways from us. If it's in front of us or behind us, though, it does appear like it is converging. Speaking of having the sun behind us, now what if the sun was behind us? How do we draw the shadow in perspective if the sun is behind us? Luckily, there is a way to calculate this too. So I'm going to draw another horizon line again. And it's essentially the same thing. It's the same 4 steps. There's only one minor difference to help us calculate the sun. So let me draw my cube here. I'll draw it low again. Just kind of roughing this out here. Okay, there we go. I've got my cube in perspective. Now, one thing to also mention, this works, this method works no matter if we're in 1-point perspective, 2-point perspective, or 3-point perspective. It does not change how this method goes on. The same things will take place. Okay, so we have our cube here. Now we want to figure out our shadow. And we know if the sun is behind us, behind us here, that means the shadow is going to be going this way. It's going to be behind the object because the sun's coming down, and going there. So that's what we need to figure out. Now, to make this easier, we're not going to start with the light source. You can start with either the light source or the shadow vanishing point on these. It doesn't really matter. You don't exactly have to do this in order. So I'm going to start with my shadow vanishing point. I'm going to start here. So this means, by figuring this out, I know my shadow is going to go back in this direction, right? This is the shape the shadow is going to be going. So I know that information now. Now to figure out the height of it, we need our light source. But if we just put our light source up here, we're just going to get the same exact results. So the only difference between in front or behind is the light source. We're going to put it below the horizon line. Yeah. So it goes down here. I know it seems kind of weird, but this is the way we've mathematically figured out. Remember, if this is our horizon, above it makes it look like the sun is behind us, or sorry, the sun is in front of us. But by putting it down here, it gives the appearance that the sun is behind us. And you'll see when we put this all together. So this is our shadow vanishing point, and this is our light source. Okay, so let's do the same thing we did before. We're going to do number 3, find our direction of light. So exactly the same as before, connecting our shadow vanishing point through our bottom corners. Just like so. Remember, we don't need to do the top corner. It's only the bottom, or the front corner. It's only the bottom 3. Actually, almost forgot there. This is the opposite because the shadow's going to be going this way. The one we don't need is the front corner because this corner won't be casting a shadow. So this line, I'm actually going to get rid of it. Forgot what I was doing for a second there, but this helps show you guys. Because it's not all the corners, it is the 3 corners farthest away from the vanishing point. So if we imagine there's a corner here, that's the back corner, then we're going to connect this to our shadow vanishing point. Okay, now we need to figure out the shape of our shadow. This is the general shape it's going to be taking up, but how long is it? So that's where our light source comes in. And we're going to do the exact same thing we did before. We're going to connect our light source to our top corner, but where these lines intersect, that's where the shadow's going to end. So we can do the same thing to this one, and this is where that ends, and then this one. Now this one, it intersects back here, which is behind the cube, so we're actually not even going to see this point, but we do know we can connect this here, to that. So now this is our shadow. So same thing, this is our direction of light, this is our angle of light. Oops, not DOS. I did in both of them. Is our direction of light, angle of light, and then direction of light and angle of light. So you start off with our shadow vanishing point. Figure out where you want to be on the horizon. Drop a line straight down to where you want your light source to be sort of coming from. And then find your direction of light and find your angle of light. And it's where they intersect, where the direction and angle intersect, that's where the back corners are going to be. And so just like before, the closer to the horizon line, the longer our shadows are going to be. And the farther from the horizon line, the shorter the shadows are going to be. Just like here, just like it's high noon, the farther away you do, it'd be just like high noon too, and you just have a really short shadow. So essentially, this is the same thing, Same rules apply. The only difference is your light source is beneath the light source. Okay? So you're not going to have to do any exercises with this. This is just something I want you to understand. So I'd highly recommend watching this video, practicing this, doing a bunch of different cubes with your light source and your shadow vanishing point, all of this, just to make sure you understand this, because this is just going to affect things how we move forward here.